So an angle bisector, we talked yesterday about angles. Or not yesterday, but whatever. I just recorded it a few minutes ago. Whenever you watched it, we talked about different angles. So here we have rays again, but you see there's 3 of them. So a ray that divides an angle into 2 congruent angles is called an angle bisector. So let's go back to blue. You'll see here we have angle ABC. Then this one, angle, well, it's ray BD, splits them in 2. So this one right here, this angle and this angle are then congruent. So BD is my angle bisector, and ABD is congruent then to, that should be a bigger swirl, DBC. Then you probably know this one from earlier math education. 2 lines that intersect, cross over each other, at a right angle form what we call perpendicular lines. So the symbol for perpendicular is this, very important in construction, because you want to have things square. So in the diagram to the right, we have line L. This is in italics. I'm writing it in cursive. So we'd say line L is perpendicular to line M. Next, my son just delivered ice cream to me. Be jealous. Let me scoot this back over. So perpendicular bisector is the perpendicular part, like we've talked about, where they intersect at 2 right angles. And in this case, it is a bisector. So it cuts, here's my perpendicular line, and it cuts right through there so that this is at a right angle. And again, when it is a bisector, the other 2 parts that it cuts up are congruent. So this right here would be the midpoint of PQ. If you don't like writing a bunch, you can abbreviate and put there's perpendicular. But then you have to remember what that means. That's midpoint. So a line, segment, or array perpendicular to a segment at its midpoint is our perpendicular bisector. So in this diagram, line LM, boy, that looks like angle. Line LM, it's an L, is perpendicular bisector to PQ. Okay, so here's some examples. We have another name for CBF, angle CBF, right here. So I can also call that the opposite, angle FBC. Now you might be wondering why I can't call that angle B. That's because I have other angles sharing that same vertex. So the sides, let me change the color here, sides of EBD, this angle right here, would be BE and then BD. Then we're going to classify this angle A, B, C. So this one would be then a straight angle. So now give an example of an obtuse angle. So I have E, B, D. You see that? That one is obtuse. All right, so two congruent angles. Let's go back and erase all of my writing. This mark right here and this mark right here mean that those angles are congruent. So it's going to be angle, we can say EBA, or you can switch it around, say ABE, and that one is congruent to angle over here, CBF or FBC. Then we've got a perpendicular bisector in this group. So the perpendicular bisector, remember, is perpendicular to the place that it intersects, and it splits the other sides into two parts that are equal. So if we see here, this is angle B, and here's this other, and we have a right angle here. And then if you'll notice, we also have these marks to indicate that AB, well, BA and BC are congruent. So the perpendicular bisector is here, and we name it from the vertex going out. So it's going to be BD.